Before modern software, before apps, before programming became a common profession, computers already existed, but they were incredibly difficult to use. In the early 1950s, programming a computer meant writing raw machine instructions, one operation at a time, using numbers instead of words. Every program was tightly bound to the hardware, slow to write and easy to break. Computers were powerful, but only a small group of specialists could actually make them do anything useful. That began to change with FORTRAN. FORTRAN, short for Formula Translation, was developed in the mid-1950s by a small team at IBM. Their goal was ambitious and controversial for its time, to allow programmers to write mathematical formulas that a computer could understand and execute efficiently. Many experts believed this was impossible. They assumed that high-level programming languages would always be too slow and inefficient. Handwritten assembly language was considered the only serious way to get good performance from a machine. The FORTRAN team challenged that belief. They believed a compiler could translate human-readable instructions into machine code without sacrificing speed. If they were right, programming could move beyond hardware specialists and into the hands of scientists, engineers, and researchers. In 1957, FORTRAN was released, and it worked. FORTRAN programs ran correctly, and more importantly, they often ran nearly as fast as carefully written assembly code. This single achievement changed the future of computing. For the first time, programmers could focus on what they wanted the computer to calculate, rather than how the hardware should execute every step. FORTRAN was especially powerful for scientific and engineering problems. It handled mathematical expressions, loops, and arrays in a way that felt natural to people working with equations rather than machines. Calculations that once took weeks to program could now be written in days. This was a turning point. FORTRAN proved that abstraction was not a weakness. It showed that computers could be programmed using concepts closer to human thinking without sacrificing performance. This idea became the foundation of modern software development. Nearly every major programming language that followed built on this principle. COBOL, C++, Java, Python, and countless others owe their existence to the success of FORTRAN's compiler model. Despite being one of the oldest programming languages, FORTRAN never truly disappeared. It became deeply embedded in scientific computing. Weather forecasting, climate modeling, aerospace simulations, nuclear research, and high-performance computing relied on FORTRAN for decades. In many supercomputing environments, it is still used today. The reason is simple. FORTRAN was designed around numerical computation and performance. Even modern languages sometimes struggle to match its efficiency in large-scale mathematical workloads. Scientific institutions also value stability and correctness. Code that produces reliable results for decades is often left untouched, even as new languages come and go. FORTRAN also shaped how programmers think. Concepts like variables, loops, functions, and structured control flow became standard expectations because FORTRAN made them practical and widely adopted. By today's standards, FORTRAN can feel rigid and dated. Early versions lacked many of the safety features programmers now expect. But judging FORTRAN by modern conventions misses its importance. FORTRAN was not designed to be elegant. It was designed to make computing possible. Its real legacy is not its syntax but its philosophy. The idea that humans should program computers in human terms. That software should be readable, reusable, and independent of specific hardware. Every modern programming language inherits this idea. Remembering FORTRAN is not just about remembering an old language. It is about remembering the moment computing became accessible, scalable, and practical. The moment software shifted from machine control to human thought. In an era dominated by artificial intelligence and automation, FORTRAN reminds us that progress often begins by making complex systems easier for people to understand. That idea remains as relevant today as it was in 1957.